Hello friends, myself Mehul Kodia from LJ Institutes of Engineering and Technology. In our last session, we discussed about dynamic force analysis of mechanism. We start a new chapter, that is dynamic force analysis of mechanism. In last session, we discussed about D'Alembert principle and some basic fundamental of dynamics. In today's session, we have to discuss main two topics. First topic, that is Newton's law of motion, and second topic, that is equilibrium of two force and three force body. Okay. Now there is a three law of Newton. You all know what is the first law of Newton indicate. If any of the object stay at rest and object is in motion, that is stay in motion, unless you apply any of the external force, at that time body will try to maintain its original position. Clear? That is the simple Newton's first law. Okay, if any of the body is in motion, at that time if you apply any of the external force, at that time a body will try to maintain its actual position. Okay, this is the first law of Newton. You all know that thing. Now what is the example of Newton's first law of motion? Suppose this ball move in the earth's surface, and unless you apply any of the external force, this ball will try to maintain its actual position in rotation position. Okay. Another good example of Newton's first law of motion, that is a simple pendulum type ball. If ball move in the motion, at that time the ball will try to maintain its actual position unless you applied any unbalanced force on the body. Okay. Now what is the second law of Newton? Clear? Second law of Newton, that is F is equal to ma. You all know this thing. The acceleration of object as product by net force is directly proportional to magnitude of net force in same direction as the net force and inversely proportional to the mass of the object. So acceleration is equal to net force upon mass of the body, or F is equal to ma. Now F indicate net resultant force, m indicate mass of the body, small a indicate the acceleration of the body. Okay, so this is the second law of Newton, and you see in this figure there is a good example of Newton's second law. If you applied force, then force will make some acceleration in the body. Okay, now this is another example of second law of Newton. If you keep ball, and ball will get some motion, and based on this force the ball gets a rate of change of momentum. This is the Newton's second law. So this is a good example of Newton's second. Now what is the third law of Newton? For every action there is a equal and opposite reaction. This is a simple law of Newton. Okay, so you see this is a good example of Newton's third law. If you push force in positive direction and apply in opposite direction, the value of the force or magnitude of both the force is same. If line of action is same for the both force and direction of both force is in opposite direction, this is the example of Newton's third law of motion. Okay, so this is the application of Newton's third law. Whenever any space shuttle is take off, at that time this is the applied the application of Newton's. You all know this thing. Now we have to discuss two theory in this session. First theory for the two force equilibrium system, and second theory, that is three force equilibrium system. You see in this figure there is one force applied in positive direction, that is F1. Okay, now one force, you see in this figure there is another force applied F2 in opposite direction. Now line of action of this force will same. Okay, and magnitude of these two force also same. At that time the net effect of this force will 0. At that time first figure is considered as an equilibrium condition. Okay, now what is second figure indicate? In second figure indicate that is a position of non-equilibrium condition. Why? Because the value of force 1 is higher than force 2. Line of action is same, but the magnitude of this force is different. Value of F1 is greater than F2. At that time that body will not consider as a equilibrium condition. one more example for the non-equilibrium condition is that if magnitude of the force will same but the line of action of force is parallel to each other. Okay, means line of action of force is not same, at that time that body not considered in equilibrium condition. Okay, so this is the two example of first one for the equilibrium condition and second example for the non-equilibrium condition. So equation of force F1 is equal to minus F2. If this condition is satisfied, at that time that body considered is in equilibrium condition, or F1 plus F2 is equal to F net is equal to 0, means value of net force is equal to 0, at that time that body considered is in equilibrium condition. Okay, so no net external force object at rest, stay at rest, Newton's first law of motion. This is the example of Newton's first law of motion, because if the value of force of F1 and F2 same and direction is opposite, at that time body will not move. Okay, if body will stay in actual condition, at that time this is the first law of Newton. This is a good example of first law of Newton. Now second, non-equilibrium condition. You see in this figure there is F1 greater than minus F2. Okay, means value of F1 is higher than F2. At that time F1 minus F2 is equal to F net is not equal to 0. At that time that body will not consider an equilibrium condition. Net external force object accelerate, Newton's second law of motion. Okay, so in this two figure, the first figure indicate body in equilibrium condition, in second figure indicate body not in equilibrium condition. This is the simple two force equilibrium condition. Okay, so now this is the good example of the two force equilibrium condition. This is the simple balancing object. If force in both the side is same, or weight of the both the side is same, at that time body will consider in equilibrium condition. But if you applied some external force in one side, at that time body will try to unbalance. So this is, then body will not consider in equilibrium condition. Okay, so this is a simple theory of equilibrium force, simple fundamental of that. Positive direction force and negative direction force, magnitude of both the direction force is same, but but in opposite direction. At that time that body considering equilibrium condition. Now we have to discuss equilibrium condition for the three forces. Now you see in this figure there is one center of the body, and based on this center there is three force act in outward direction. First, that is capital L force, second is capital W, and third is capital D. Now you see in this figure capital D, the direction of that force make angle small a with x axis or with horizontal axis, and capital L, force capital L make angle with vertical axis, the value of angle that is small a, and one force applied in downward direction, that is capital W. Okay. So if we have to consider this body is in equilibrium condition, at that time the total force of this body is 0, or resultant force of this body is 0, means L plus W plus D is equal to 0. Then and there this body considered as a equilibrium condition. Now for learning this topic you have to understand some basic terminology, that is capital H. Now capital H indicate horizontal forces, and second capital V. Now capital V indicate vertical forces. Now if any of the force applied at some angle, at that time that force have two components. First component is horizontal component and second component is vertical component. If D force make one angle with x axis, that is small a, then this D force have two components. First is D sin theta and second is D cos theta. D sin theta applied upward direction, D cos theta applied horizontal direction. And capital W is equal to weight of the body. Now weight of the body always applied in downward direction, and equation of this force, that is W, is equal to mg. And capital D indicate drag force and capital L indicate the lift force. Okay, and small a indicate angle. Now D force and L force make same angle with horizontal axis and vertical axis. Okay, that the value of that angle, that is small a. Now this body will consider in equilibrium condition if addition of horizontal forces is equal to 0 and addition of vertical forces is equal to 0. Then and then this body will consider is in equilibrium condition. Now you have to calculate, or you have to compare total upward force and total downward force. Clear? This is a sigma of vertical forces. So vertical forces, now you see in this figure, there is one force vertically applied downward direction, that is W, and there is one force applied D, the component of vertical component of D force, that is D sin theta, and vertical component of L force, that is L cos theta. Okay, so you have to add the vertical forces, all the vertical forces from this diagram, and you have to add horizontal forces from this diagram. Okay, so this is a simple trigonometry. So you have to add the vertical forces. So vertical forces, that is capital W minus L cos A minus D sin A is equal to 0. This is the addition of vertical force. If addition of this force is 0, then this body consider in equilibrium condition. Now you have to compare total positive directional horizontal force and total negative directional horizontal force. So in positive directional horizontal force, that is D cos theta, and total negative directional horizontal force, that is L sin theta. So D cos theta minus L sin theta is equal to 0. So if these two condition is satisfied, then and then this body consider is in equilibrium condition. Okay, this is the 3-force equilibrium condition. So in today's session we discuss about 3 law of Newton. First law of Newton indicate if any of the body maintain its actual position unless you apply any external forces. Second law of Newton, that is F is equal to ma. Third law of Newton, the action and reaction of the force will same. And we also discussed 2-force equilibrium system, and this is the 3-force equilibrium system. So next topic we will discuss in our next lecture.